I'm Hendrik. Thank you, Michael, for the great presentation. He showed a lot of tools that we learned to love over the last month. I became especially familiar with BigQuery in this time. Now I want to speak about a project that we worked on in our team and where we utilized the Google infrastructure. So I want to talk about the background and motivations a bit, like what moved us to do this project and what we wanted to achieve. Lin will then cover the design principles, like everything around BigQuery. He's a staff engineer on our team. And we will have James, a senior engineer on the team, then talking about the orchestration we did with Composer. I think Navet gave a pretty good introduction to what Double Verify is doing, but just to recap, and probably most of the people here know what we are doing, but just to be safe. So we are helping our customers to verify that their ads are actually working and to improve their ads. So we're actually doing fraud detection, content classification, viewability measurement, geo measurement, and that is done using a tag that they actually use inside their ads. And one part of what we offer is that you have, as a customer, you can log in and look at the post-bid reporting, and then you will see all the numbers around your ads, and then can see did it work the way that I wanted? But doesn't end there. So basically what you can also do is actually use the data that we collected and then make sure that when you run your next ad campaign, like when you're serving ads the next time, that you're actually not running into the same problems. So you basically use something we call pre-bid activation, and that helps you to, on the next time it is running, it helps you to avoid fraud, avoid brand safety incidents, make sure you hit the right contextual content, and in the best case also get a viewable ad. Because if it's not viewable, then you don't want it. So this pre-bid activation, when it's actually working in the programmatic advertising, so basically there's programmatic advertising when you run your ad campaign and it's served in real time to the place you want your ad to be. It's a whole ecosystem of partners in this space. So basically they are all connected. Some user walks onto a page and then information about your page visit, it goes into one system and then it travels through all the systems and they all look at this bid. They all have to decide, okay, do I want to put my ad there or not? Then some kind of auction takes place and the one that actually offers the highest price gets to place their ad there. There are ad exchanges, SSPs, ad networks, DSPs, they're all connected. And to actually know if they actually should place the ad there, they need our data. And since they don't have it just magically in their system, we offer them a way to actually get it in real time, and that is using the third-party data there, and that is an application that we built called IQ Connect. And this application is actually an API that you can connect to, and you will get in real time, you will get an answer from us telling you if it's fraud, if it's not fraud, if it's brand safety, if it's likely viewable or not. The thing is that this IQ Connect application, it's a massive thing. It was built a long time ago. And the partners we are working with, they are actually all over the place. So they have their own hosting situations. They are working in different regions across the world. So when we deploy this application, we have to be close to them because it's happening in real time. So we can't waste a second to wait for the answer. Basically the user has left the page. So what we do is basically we deploy our IQ Connect application in different regions. We deploy it in co-location. We deploy it in the cloud. We deploy it on the side of our partners, always depending on where they run their stack, where the partners are actually running their application and where they need our data. That actually introduces a lot of challenges because the whole project that we did, it's about finding out what the application is handling. So what we want is we want to get some kind of feedback that tells us, okay, like what did the application process? What were the bits that we are seeing? Like where do the users visit a page? Like where are they coming from? So we can actually like ingest this data and then use it to refine the data that we are processing, that we are providing to our partners. So we need to, like, from all those instances across the world, across different hosting situations, we actually need to get this data back to us where we can process it. So, and it's a lot of data. So like this is actually huge files of data that we actually need to retrieve and like need to get into our system so we can process it. Of course, like we did this processing before. So we had some kind of solution in place before we logged CSV files. We had a host of different situations. I think like the SRE team knows how painful this is, like that actually collect the files and move it to a central location. Then we had a Vertica database where we had a process that is running all the time, that takes the files, moves them into the database. It's painful because if it gets too big, then we get problems. It gets stuck. Like we have a lot of people having to maintain that. Then whenever the data gets too big, like we have to basically, like, it's not so easy to increase the capacity of Vertica. Like you need to do a huge operation, you have downtime and so on. So like it was over the last years, it was always a big pain. So now we finally had the chance to do something about this. So when we started thinking about the migration, we defined, okay, what do we need to do? Like first, we need to provide like basically the same functionality that we had in the old system. We needed to be able to store the same, like to have the same capacity, store the same data. We needed to support like the same data structure. Like we wanted a solution that you can query the same way, access the same data in our files. We also needed to offer the same integration. Basically, like all the consumers that we have across the company that are actually like trying to use the data, that consume the data, they needed access, they needed to consume it, they needed to run their query on this. And we needed the same tooling. So you needed to be able to use SQL to access it. You needed to be able to point your dashboards at the data. You needed some monitoring. But beyond that, we also wanted to enhance our current situation. So basically, like investing a lot of time, and then you end up with the same solution, like, or basically something that offers the same functionality. That's not great. So what we wanted to do is we wanted to store more data. We wanted to be able to like log more. We wanted to be able to hold the data longer in our database. We wanted to like scale easy. So if the data was growing for whatever reason, like we wanted the database to be able to hold it and not have some kind of like maintenance all the time. We also wanted to be able to like store the data in a better way. Like we have columns that hold lists of numbers. Like those columns we wanted to access the number, not like some string that just like held unstructured data that you have to parse using some kind of regular expression. Like we wanted to make it easier for the user to actually use the data that we provide. We also wanted to create something that could be used easier across the organization. So like other teams should be able to use the data in their systems. Like we didn't want to force them to use BigQuery, although like maybe it would be nice, but yeah. So other teams have other opinions and they have other use cases. So like we needed to be open, to offer a solution that works for everyone. And we also wanted to like provide more tools, visualizations, analytics opportunities, and support data-driven decisioning. All these were our goals, and I think like what I didn't write down, like above all, like I wanted to have a solution that is simple. That is just like, if you look at it, like you should say, okay, that's it. Is it that easy? Like, don't we need more components, like more modules, like more transformations and so on? So like, it should be something that is just like working and like it's elegant, simple, easy to maintain. And Lin will talk about how we actually did this.
Thanks, Hendrik. So I'm just going to show you how elegant the solution is, right? Just bear with me. But I think I guarantee you when you go to the end, you will see, oh, it's really that simple, right? So before I dive in, I want to kind of address first why we choose BigQuery, right? So there's a lot of reasons for that. Let me just go through them a little bit. So I think the most important reason is our team, not just our department, but across DV, engineering and product, a lot of team already using BigQuery. So like if we were to introduce something new, so there would be like deep learning curve. So the migration wouldn't be so easy. So I think that's number one reason. And obviously there's a lot of rich toolings provided in the BigQuery, not just in the BigQuery, but also in the Google Cloud, right? For example, the PubSub and the Composer, which Michael mentioned. I think, James will talk a lot more about that, but like this one give us a lot of tools which we can try things very quickly and build something better, right? And the second one is the pricing part, right? So when we start to look at this project, we told ourselves we want to build things responsibly. So we not only want to build something better, but we want to build something cheaper, right? So BigQuery offers very versatile pricing models, including the separate storage and computing. And inside storage and computing, they have different kind of billing types. So we took full advantage of this to build something very cost effective, which I'll demonstrate later. The last point is the openness, which we kind of seeing a full-fledged demo where how we can integrate well with Databricks and Snowflake, as well as the open table format Iceberg, right? So this makes integration with some other team much more smoother. Obviously, the last point I want to touch is the Google support. It's fantastic, right? I see like 6 Google people are here on site to support our presentation. I think this has been a great partnership. Now, this is a very kind of high level overview, right? So, but I want to touch this so how this thing goes, right? So on the left side, it's a data source, which I think Hendrik mentioned, where our IQC connection spread across globe. We have a few hundred instances, very low latency requirements. So, but these are the data source. And on the right-hand side, we are supporting all the use cases, right? So I think it's worth to talk about the use case a little bit because this one is going to drive how we design our system, right? Which is in the middle. So by and large, most of the use case are the analytical use case. What does it mean is like we have a lot of, product people, engineering people, they're not really interested in looking at, oh, give me just this particular log, but they want to see, oh, what is average trend analysis, like aggregation. So, which means, they are doing the analytics use case, not the transaction use case, right? So this has a big implication for us because, if you know a little bit like about the database kind of layout, we are really looking at like the column oriented, where you can do very quick like average those kind of operations. So this will have a big impact on our design. But I just want to mention here, and in the middle, it's more like the bulk of our work. How do we kind of move the data into the BigQuery, and how do we open up the interface for our user to aggregate analysis, as well as we have tons of the automated pipeline, including our downstream partner in Israel, like do the fraud detection, as well as we have like hundreds like dashboard, which is constantly running to provide business intelligence, right? We need to build a system to support all of that. On top of that, we also want to unlock the value to do more advanced analytics, like Michael mentioned, like generative AI, machine learning, which I think James will talk about. We want to set up foundation to unlock all these business opportunities. So now this is I think Hendrik already mentioned that, so I will just briefly touch that. But what I want to highlight is the latency requirement is very high, right? So which means we cannot afford to make this data source our bottleneck, right? So which means we have to, like, our decision is like, we don't want to completely change the approach before, which is before that was like we constantly flush out the data into the CSV file, and then we kind of migrate outside of this critical system. So we are taking a similar approach, but we are making some enhancement, right? So the first enhancement we did was, we migrate from the CSV file to the Avro file, right? So CSV file is very human friendly, but it has a lot of downsides, right? Just to name a few. So it doesn't have a schema, right? It doesn't support the complicated type like array, and it cannot be compressed, right? Because it's, nobody knows what's inside, right? So now first thing we did is we convert that to Avro file. Avro file is self-describing because there's a schema in it, and it's like have fantastic compression ratio, and it is also kind of support all the complicated structures, right? So, and it made a huge difference in terms, how we can make the files better and smaller, right? So because when you transfer that in a network, the bandwidth, everything will just reduce by a lot, right? So that's kind of the first big improvement. But I think, remember, every file is still like row level. So we still not to our final destination yet, which is we want to go to the column level format, right? But, we'll get there. So the next step is, I think, so what do we do with this every file? Now is accumulating on the local machines, right? Like I said, we want to move it outside this like a critical place, right? So obvious solution is we want to migrate to BigQuery, then we need to move it to the Google Cloud, right? So we chose GCS, Google Cloud Storage, which is pretty standard solution, right? So what we were facing at the time is there's not just one, like Google Cloud Storage has different kind of storage format, right? So the default is the US multi-region, right? Everybody almost like choose that without thinking, right? So, but because we said we want to really make things like responsively, so we compared different kinds of, type. So there's US multi-region, there's dual region, like, and there's also single region, right? The key difference between these three is like, for the multi-region, they are kind of duplicate data and transfer data like constantly, and user doesn't have no clue what's happening, right? So you don't know, like, but this is by design because you don't want to, it's like backup. But, for us, we don't really care too much about the duplication because it's an analytics system and it's logging. And I think we can afford to lose a little bit like availability if we can achieve a huge cost cutting, right? So we did some like experiments, and what we found is by switching from multi-region to single region, we can reduce the storage cost by almost 70%. Right, so that's why we chose a single region. It has some like downside, but but we kind of have some remediation to kind of compensate that. Then the next one is now we have the Avro file lived in GCS, right? So what do you do about that? You cannot just accumulate that there. Just we haven't even touched BigQuery yet, right? So what do we a naive solution would be just, okay, so you got every few minutes, we just go to the GCS, see, okay, how many Avro file are there? Then we just process it, right? But, the downside of that one is you have to remember what are the file you processed before, because, if you don't remember what you processed, you ended up like process a lot of, file multiple times, right? So I think, there's a good feature in the GCS. It's like seamlessly connected to the PubSub capability, which Michael mentioned, where I think you can set up a notification and it will just push all the new files, the metadata. It's just a file name, right? Because you just want to know the destination, the UI of that file. So it constantly push the file name into a PubSub topic. So this is a very beautiful solution because the PubSub topic is just nothing, like it's similar to Kafka, right? So it just accumulate there, so you don't have to rush to process it. You can just process with your own like controlled pace. So that's exactly what we did. So coming to this one, so because we put in a lot of thoughts into the Avro file format, so what we need to do is really very simple. We just need to load that Avro file into the BigQuery. We don't need any transformation ongoing. That is very crucial because of that, we can actually do the BigQuery batch load operation, which is free of charge, right? So imagine you have to do all transform like terabytes, petabyte of data. Like no matter which tool you use, you have to pay the money, whether you do the BigQuery or you set up your own process. And if we choose big batch loading, then you can just process it. BigQuery just kind of free service. It's kind of, it's beautiful, right? So, and what's good about this batch load is also it's atomic, right? Because this is very important because we are loading on a normal case, we load maybe about 1,000 Avro file in one load, right? So now if it's not atomic, you ended up with some intermediate states. Your data will be corrupted. It's just not good, right? So, but the atomic operation will guarantee if there's one file is corrupted, everything will fail. So you can implement the retry logic to just get rid of those corrupted file and load those 999, right? So, and what is more important is BigQuery provided the default column value feature, right? So you can define your schema to add a column to say, I want to provide a solution, I want default value for this schema. For our case, we just say current timestamp. So if you do that, then all the all 1,000 Avro file being loaded, let's say translate to 20 million records, will all have the same unique timestamp associated to it, right? So this is very important for us because, remember, we have to push that to the downstream partners. We can use that timestamp to uniquely identify what are the new like records being added into BigQuery. So we can do the targeted query. And we add some like index, obviously, in BigQuery it's not indexed, but you can just do that process very quickly. So I think this is the final solution. I think what I want to touch is like, if you look at this one, it says we use a native table, right? So what does it mean is we kind of load everything into the BigQuery's internal storage. And the internal storage format is called capacitor. It's a proprietary like format. Think of them as a packet format, but it's also column oriented, and it has a actually very good compression rate. So in hindsight, this is really, really good solution. This is what we came to, but because first of all, it's very simple. Like Hendrik said, we want to be something simple. It doesn't have much dependency. Everything is everything is serverless. You don't have to you don't have to set up any resource, right? You need use GCS, PubSub. We use a composer to do a lot of orchestration. James will touch that in the later slide. And then performance is very good because it's everything is in the BigQuery, so engine storage, so it can do a tons of optimization, and it is also very important because native table you can do for read and write, so it's very easy to say manage the PI data. Let's say you want to delete some column, something which is out of retention, then you can do it. And but this is not what we pursued at the beginning, right? So, and the reason is we were under the impression capacitor, that's format, compression rate is very bad, right? So I kind of, because we at the beginning we said, oh, we want to build something cheap, right? And a lot of cost is determining how much data it is, right? And it boils down to, can you compress your data like to the extreme, right? Remember, we go from CSV to Avro, now we go capacitor, and we say, okay, so we were under the impression packet format is way better. So that's indeed what we chose before, right? If you look at this one, this alternate solution, what we did is pretty similar up until like step 3. where we introduce the Spark procedure, right? And then we use this Spark procedure to process all the ever file into the package file. And we put them into another GCS bucket. Then we create an external table for that. And then you can run the federated query. Like federated query means, you query outside the BigQuery, just use the BigQuery engine. So this works, but it's very complicated, a lot of side effect, right? So now you introduce the Spark procedure, and then when we test it, you cannot delete data using SQL. You have to use the Spark to do that, which is like very, very cumbersome for us. And then performance is not that great. And most importantly, the cost is just kind of double. The whole thing just costs double. So at that point, we say, okay, so it can't be like that. We messed up, right? Something was wrong, right? So we went back to reevaluate our assumption, which is like capacitor compression rate is bad, right? So we did a full POC. We put some like real data, and we did the packet conversion and capacitor conversion. What we found was a very big surprise to us, and it's probably because our data is like the compression rate for capacitor is as good as packet, if not better. So at that point, we said, okay, so no, this is really kind of what we want to pursue. That's indeed what we did. Then that's what you see, the beautiful solution we presented here, right? So now let me quickly go through some other cases here, right? So this one is like really want to address how we can manage the user experience when they do the query on the console, right? So the thing which is important here is how do we manage permission, right? So just to go through this example, right? Let's say we have a source data, which is data set. We have every single data in it. We have very strict permission for this one. So not many people can query it. And then we create a separate data set where you can define like a shared view. A view is nothing more than a logical SQL where you define like how many fields you want to expose. And then, for the analysts, they only have access to the shared view, but they don't have the source data. So, but we use this authorized view to allow the shared view to access the source data. So that's how we do it. And another thing we did is like the partitioning and the clustering, which is like, out-of-box support from BigQuery, which we can dramatically improve the speed. And this is the use case I talk about for the fraud dev. So I'm just quickly go through that. Basically, if you look at this one, the number one is you go to find the insertion time, allow time, like then you publish that to the pub subtopic. And then, for the Cloud Composer, you can just go there and launch get all the new data, which I mentioned, to send to the downstream partners, right? So the last two slides is really kind of focused on the cost storage. So for this one, I was talking about the storage. So storage has a logical and a physical billing. And if you look at our data, if you choose the logical billing type and versus physical billing type, you see the difference huge. And it's worth to like mention BigQuery by default is logical billing. So if you don't do anything, then you will end up like paying a lot more than necessary. So do make sure like you know your data and do the homework, right? The other one is the cost optimization. So again, there's on demand and capacity. Like one is based on the data you scanned. The other is based on like, how fast your query runs. And for our case, because our data volume is huge, right? So if you compare, like this is just one simple query. If you compare the on-demand, we scan tons of data, and because we did all the performance and the query runs very fast. And if you use capacity based, then it's like 200 times difference, right? So this is like a lot of things we put in to make this project very cost effective. Now I'm going to pass to James to talk about the orchestration and some pipeline and some feature work.
Thanks, Lin. I'm going to talk about the role of Composer in this project. So most of you are probably familiar with Composer and Airflow, but Composer is a GCP service. It's a managed service that provides Airflow, and the Airflow is a scheduling and orchestration platform. So why did we choose to use Composer in this project? There's many scheduling tools out there. So the first reason why we chose to use Composer is experience with Composer at DV. On our team, we track hundreds of processes in Composer already. So we can just extend our existing infrastructure and practices for this project. The second reason why we've chosen to use Composer is just to have all the benefits of a managed service. So that includes reliability, scaling, cost savings, and support and updates. Another reason to use Cloud Composer was just to have all the Google Cloud integration, including all the tooling such as monitoring, logging, as well as Google provides some Airflow operators that make it easy to use PubSub and BigQuery for the operations that we needed in this project. And lastly, we have good experience using Airflow's management UI to track our processes. So we'll actually take a look at the Airflow management UI here to see these processes and how they work. So here's Airflow's, here's all the logging tasks for this project in Airflow. So this is a list of DAGs. So the first DAG that we see here is the main log loading DAG. So this will pull the file names from PubSub and load them and load the files into BigQuery. We also have another DAG below for the unclassified URLs, which is a similar log loading operation, but specific for a piece of the data set for URL classification. And at the bottom, we also see that automated pipeline DAGs, which Lin touched on. It's an export feature to get some data to other parts of DV for analyzing our logs. And we can see that also that everything is running successfully, so that's good. And we see that these DAGs usually run about every 5 minutes. So it's good to have this data be ready relatively quickly. So here is if we click into the load logs DAG, that main process for loading log data into BigQuery. So again, this is the process that pulls the file names from PubSub and loads into BigQuery. So on the left, we see in the green, we see the history of successes with the individual task level. So we see that we're loading data into BigQuery successfully. And then on the right, we see a little bit about how this DAG, how the tasks in this DAG relate to each other, and how the process works. So we see that we basically have 3 steps. We pull the file names from PubSub, then we combine those file names together, and then we load them into BigQuery. So it's pretty simple, and we can actually take a quick look at some code snippets and some stubbed out code to see that this is relatively easy to do in Airflow. So let's take a look. So these are the 3 tasks inside the process. So the first task is actually a group of poll tasks, and using a group for this allows us to run them in parallel, which just saves ourselves from accumulating a little bit of latency. And so we pull the maximum number of file names from PubSub 5 times. So this is why we have to do multiple polls. The next task is going to combine those polls. So here it's the implementation's not shown, but this task will combine those file names, but it will also separate those file names into the different Avro schema versions. So this is something we haven't touched on yet, but we do have schema evolution here. So if we want to add or remove fields from our logs, this step allows us to separate those different versions so that we can load each version in its own load task in the third step. So the third step, we see one more Airflow feature here that makes this easy, and that is the Airflow's dynamic task mapping, which means that for every list of each Avro schema version, that's the result of the combined task step. We will create a load task. So if there's no logs at this point, then the load task will now run, and then it'll run as many times as necessary. Yeah, it's pretty simple DAG overall. So here's just a quick example of what happens if something fails here. So we'll see that in the Airflow UI, you can see the failure pretty clearly. And so what'll happen is that the process will attempt to retry. And if the retry fails, we get this nice red square here. So it's very clear that it's failed. And then we can look at the logs here inside Airflow. And we see in this case that there was an issue parsing an Avro file during the load step. So the data wasn't loaded into BigQuery. And so early on in this project, we had some issues where every now and then IQC servers would write out malformed Avro files. We try to keep our failure rate low because for now we have a manual recovery step for malformed data. So we've gone back to IQC and tried to improve making sure that we're only outputting well-formed files. And so, yeah, actually, so we've seen that these Airflow processes are working and that we're starting to deliver on the goals of the project. So what else are we excited for in this project and what's next? We've heard a few presenters mention Big Lake Managed Tables, and this is a GCP feature that's in preview right now. And so we see that it might map pretty well to this use case. So we have tried so this is a table that is information provided by Google. And we've tried pretty much all the 4 columns on the left here in some capacity during this project. And we decided that native table was strongest for our use case. But we will be looking into Big Lake Managed Table because of the open table format of Iceberg, and that it could help our interoperability with other teams within DV with Iceberg and using other systems such as Databricks, et cetera. What else are we looking forward to? So BigQuery ML would allow us to use plain SQL to create and train machine learning models. So with this, we can see that it might be very easy to do POCs on with machine learning and go to market very quickly. So we're looking forward to this use case as well. And I think that's it for our presentation.